Okay, we are in a discussion of AWS solution architect, right? And another discussion video today, uh, we are still going to talk about high availability and fault tolerance. And today also we're going to talk about a shared responsibility model, which is how much percentage customer maintaining of these services as well as AWS maintains, right? All right. Um, let's get it started, right? All right. So we've been discussing high availability and fault tolerance, right? High availability is minimal downtime for application services through redundant component, right? And we achieve this one using and distributing workload across multiple resources and then operate across multiple availability zones, right? And then fault tolerance, right? Fault tolerance is ensure functionalities through built-in component redundancy, so automatic recovery from component failures, right? Continued operation during disruption, so sort of business continuity with fault tolerance. Sorry. All right. So just going to discuss a bit of elastic load balancing for high availability and fault tolerance, right? Elastic load balance is uh, in the front of EC2 instance, right? What it does, it distribute traffic into EC2 instances where they're located in different availability zones, and then they automatically check health checks with these elastic load balancers, and then they take actions accordingly, whatever the rules we are putting in. So we just discussing is a sort of general high availability and fault tolerance, not going into deep into elastic load balancing, whatever, like how do you put health rules and all other stuff. They will be another sort of video, but this is in a sort of a general condition. How do you achieve this one, right? So we have three type of elastic load balancing in Azure Cloud. So the first one is application load balancer, right? Which is so in a layer 7 HTTP and HTTPS layer 7 load balancer, right? And then TCP UDP layer 4 network load balancer, and then you got a gateway load balancer, which is we use for third party appliances. So mainly we got these three load balancers, right? In the picture of underneath, you can see how the load balancer, elastic load balancing works, right? So it spreads through two availability zones here in here, and this is the load balancer. So they got two front-end servers, EC2 instances, and then in the middle layer you got the application server, and the back-end layer Aurora RDS instance is running, right? And this traffics will be balancing with this one, right? So outer world, so the traffic will be they will contact load balancer to access this uh, program or whatever running in there, right? And so the benefits of high availability and fault tolerance, right? automatically route traffic away from all unhealthy instances. So let's say you got one of the instances here, right? And it's unhealthy, then it will automatically switch off the traffic going into that, right? And then it will add another instance into one of the availability zone for that one if auto scaling is enabled in there, right? Cross zone load balancing improves fault tolerance, right? So cross zone means different zones, right? And then cross zone mean is something like this one is that these are regions, right? So work across multiple availability zones for resilience. So it works with multiple availability zones, right? And support health checks to detect failed components. So constantly checking health checks into regular intervals to check whether the is there any problem with that instance that program is working, or if there any problem with that instance, so it will generate another instance in a different zone to make sure that high availability and fault tolerance is there, right? So, auto scaling for resilience, right? So, this load balancers and EC2 instances use auto scaling for resilience, right? And this one we can use different sort of rules like simple rules, step rules, and some other rules we get to talk when we are creating auto scaling in AWS portal. But actually, we can use CloudWatch integration. So CloudWatch matrix, CloudWatch collect the matrix, and so you can use various matrix to scaling them out, right? So you can use CPU utilization. As an example, let's say you need to get another one more instance if the CPU utilization goes over 80% of one of the EC2 instance, or you can check network through output. Let's say you got a high network bandwidth is allocated, uh, is consumed, and then you want to get another instance to uh, get the traffic to another instance. So you can use a network through output as well as any other. There are so many other custom matrix you can use, whatever collecting in the CloudWatch integrations, right? Um, Key features automatically adjust easy to instance based on demand. So we can make rules to make it more instance or remove terminated instance when a load is less, right? Replace unhealthy instance automatically. So it checks the health check and replace unhealthy instance automatically, right? And support multiple availabilities on deployment. You can see in the load balancer here, right? This is availability zone 1, availability zone 2. So we got two instances running here. We got two instances running here, right? See that this instance having a trouble. That's what it says with the triangle here. So it will remove this instance. This one is health check failed, right? This was his health check is okay, and then it will generate another instance here, right? Auto scaling replace unhealthy scale based on load, right? Use launch template for consistent deployment. So uh, we can create launch templates. Launch templates are the templates with the standardized settings and same setup as of one of these instances. So it use one of the launch instances, launch template to generate a new instance instead of this unhealthy instance. So that's how auto scaling keep everything for resilience. All right. Then now we're going to talk about AWS database services for high uh, availability and fault tolerance. So we've been discussing with EC2 previously, auto scaling and load balancing, right? Okay, so in this case, right, we just need to understand there are two type of synchronization, right? So one is called synchronous replication, right? And the other one is called asynchronous replication, right? Read replicas. The first one, multi-availability zone, right? And so just need to understand before we going into fault tolerance and high availability in RDS instances. So let's have a quick look what is this synchronous replication multi-availability zone, right? All right. So in a synchronous replication, primary database waits for standby replica confirmation, right? So synchronous replication means so whatever writes in the primary database will be written into standby replica, and it confirms I got the data, and then that is started again writing, right? So zero data loss during failover, right? That means RPO, right? Uh, that means is anything in a primary DB will be in a replica, standby replica. So one thing we need to understand is we can't use the standby replica for read as a read replica, right? So standby replica confirm it got the data and then start primary database got a confirmation. It wait until confirmation. So if anything happens, automatic failover will happen within 60 to 120 seconds, right? This is really good for mission critical applications, right? So you could see underneath that picture AWS RDS multi availability zone architecture. So availability zone one, you got primary RDS instance, right? It's active and it got a read, write and read operation. So it got a write and read operations, and then it synchronous replication against its standby DB, passive standby one in availability zone two, right? And then primary database synchronized replication in a standby database, which is passive, right, is configured to automatic failover, right? Only thing you can't use this one until the primary database failover, right? And then the second method is the synchronous replication we call read replica, right? So in that case, primary database doesn't wait for replica confirmation, right? Doesn't wait until doesn't wait to ask from a read replica to tell I got the data. So eventual consistent with possible replication lag. So it got a little bit lag in between the data in a primary database and read replicas, right? Um, that's needed a manual promotion required for failover, right? And perfect for read heavy workloads, right? So these asynchronous replication, right? They read replicas, they call read replicas, they can be used uh, for reading queries, right? If you have a program which is use heavy read workloads, so you want to read so much data, so you can use read replicas for part of this workload from primary database to the read replica. So read replica can work as a um, reading workload while it's a replication, synchronous replication with primary database. So just need to understand the primary difference between these two. Synchronous replication is multi-availability zone, but it's a standby database. Also, it wait until read standby database so telling until I'm finished with whatever you send me written down. So there's no any different database, right? But asynchronous replication with the read replicas, you get a bit of a lagging in between. So whatever primary database has just a slight difference in read replica. It hasn't got everything from a primary database yet. So here in feature, right? So synchronous and asynchronous, right? So consistency, strong consistency, right? Zero data loss, right? And asynchronous read replicas, you got an eventual a little bit small lag, possible lag in there, right? Failover will be automatic with standby passive DB, and then asynchronous read replicas, you need to manual promotion, right? And then use cases, uh, synchronous, high availability, right? Then second one is read scaling and disaster recovery scenarios. You can use the read replica, right? And Aurora is special case. Aurora use quorum based storage with six-way replication. Read replicas have low lag due to shared storage architecture. So Aurora uses quorum-based storage with six-way replication. So you got a six-way replication. Read replicas have low lag, very little lag, nearly there. So due to a shared storage architecture, right? That's what we need to remember, right? AWS database as service for high availability and fault tolerance, right? Um, Amazon RDS multi-availability zone deployment, right? That synchronous replication to standby instance in a different availability zone, right? Synchronous. And then automatic failover with minimal downtime, right? And maintainers performed on a standby first, right? So then we got Amazon Aurora, right? Uh, you can go up to 15 read replicas for enhanced scalability. So if you have very big, heavy reading workload, you can go up to 15 read replicas, right? And it also has automatic failover capabilities, right? It has a six-way data replication across three availability zone, right? And it got a self-healing storage. Those are the features of Amazon Aurora, right? Um, Database failover times comparison, right? And we comparing the database failover comparison. So how long will it take? So self-managed databases are the ones taking more time, right? And standard RDS in the middle, it's taking time of the middle, but Aurora is very fast. It's very less less than 50 seconds. Is that yeah, time in a second? So guess less than 50 seconds. The standard RT is somewhere between around 75, 80, and self-managed databases is around more than the 200 means 3 to 5 minutes or something like that, right? All right, so let's go into this one. This is Route 53 and Global Resilience Service. That is AWS DNS service, right? Well, this Route 53 is doing a very big role in automatic failover scenarios, right? Uh, Amazon Route 53, right? Used for DNS failover, routes traffic to healthy endpoints, right? We saw we can do it in a EC2 as well as I think we had a look in a previous video, right? And can use a weighted routing, distribute traffic across regions. So it can distribute traffic across regions, and latency-based routing directs low latency endpoints. So it can direct traffic to low latency endpoints, right? And we're talking about Amazon S3. So Amazon S3 is 11 nines durability, right? 99.99s, right? And use cross-region replication for disaster recovery, right? And the other one is CloudFront global content delivery network. This caches content and edge locations. Edge locations are everywhere in the world, so many places, right? Reduce dependency on origin servers. So it gives you a cached content, so it doesn't always doesn't need to depend on origin servers where they are located to bring the traffic into another location in another geographic region, right? Right. So next one we got is manage high availability fault tolerance services in the AWS Elastic Beanstalk. So this Elastic Beanstalk fully managed service that handles automated deployment, right? And automatic scaling, and can use the load balancing across multiple availability zones, and also can do health monitoring as well, right? And then we got Amazon ECS, Elastic Container Services. It has a container orchestration service and run container across multiple availability zones, and then automated container recovery, right? And the other thing is AWS Global Accelerator, so it has static IP addresses. Just do intelligent routing over AWS global network, and it's usually a fast failover to healthy endpoints, right? Okay, so best practices for high availability and fault tolerance in AWS, right? We also discussed this one in some of the previous videos, just in a point form in this one. So multi-availability zone deployment, right? So deploy critical workloads across at least two availability zones for resilience, right? At least two availability zones. And then automated backups, implement regular backups using RDS snapshots, EBS snapshots, and S3 versioning. So make sure you have good backups. Anything happens, you can recover fast. And then health checks and monitoring, use CloudWatch alarms and AWS System Manager for proactive monitoring. So these two services we need to talk separately, CloudWatch and AWS System Manager. Uh, Stateless design, use S3, DynamoDB, Elasticache instead of logical storage for shared state. So just telling use reliable services like S3. It's automatically replicated across three zones, and you don't need to do separately. So DynamoDB and Elasticache instead of local storage, like sort of all depend whatever you want, right? So it's a small diagram underneath. You can see AWS applications, right? So high availability, multi-availability zone deployment, you achieve that, and then fault tolerance, automated backups, and health monitoring, state design, right? So the all improved availability of these services. So it ultimately uh, go to high availability and fault tolerance for these services, right? Right. So let's briefly discuss, because this is sometimes they ask these things. What these cloud services? They're always going to be a shared responsibility model. The service provided, right? Hardware and all the service provided to a certain task, and then the some of the other tasks are up to customers who buy those services, right? What is the shared responsibility model? A security framework that clearly divides responsibilities between AWS and customers to ensure complete cloud security coverage. So this is to make sure your services are um, running securely in the cloud, right? Because some people think they can be can like, if you doing any IT related sort of IT responsibility job in your own premises, so a lot of things in your hand, right? Like physical securities, and that, like software security and user security things. A lot of things are in here, just like that in a cloud. You got separately areas looking after by AWS and their responsibility, and there are some parts which services they have customer responsibility as well, right? So why it matters? Establishes clear security boundaries. So it establishes clear security boundaries within the AWS cloud. uh, who is going to do what, right? So prevent security gaps and overlaps, critical for compliance and auditing, right? So, so the model separated what need to be done by AWS and what need to be done by customer, right? Breakdown of shared responsibility by service type, right? And this is a sort of a breakdown of a shared responsibility, right? Uh, by service type. So IaaS, right? What is IaaS? infrastructure as service, right? And then what is PaaS? Platform as a service, right? And then what is SaaS? Software as a service. So infrastructure as a service, right? So it got about 70% responsibility distribute towards customer in that services, and then platform as service is about 60% of responsibilities go towards AWS, and 40% goes to the customer. And software as service, mostly 90% of responsibilities goes to AWS, while uh, very little, about 10% responsibility goes to customer. So just like take an example, just software configuration, this sort of things. Uh, if you're looking into the first one, it's the infrastructure as service IaaS, IaaS. So example is EC2, VPC, and EBS, right? So in that case, AWS look after physical infrastructure hypervisor, make sure they all up and running with the all physical connections are there, right? But then customers' responsibilities, operating system patches, application security, encryption, all other things become customers' responsibility, while mostly AWS looking physical infrastructure and providing power and everything to run your services, right? And customer, if we look into it, it's a very simple example. Like if you got a Windows machine in there, virtual EC2, so you need to make sure you patching is your responsibility in there, and application security and data encryption, that's a customer's responsibility. Platform as a service, right? Platform as a service examples are RDS, relational database systems, Lambda, Elastic Beanstalk. So AWS do infrastructure, OS, and patching. That's all the underlying layer is looked after by um, AWS. So customers' responsibility is when you're using PaaS, so data access, identity and access management, and you have to do backup of your data. So they are coming into a customer's responsibility. Software as a service sort of things like Amazon Connect, AWS managed services, whatever mostly managed by AWS services they're providing. So AWS does nearly everything. The customer got only little, very little user access and data classification. Those are the things a customer need to manage. So you need to remember in when it goes to infrastructure as services too, software as a services, the responsibilities of customers decreases and increases of AWS ones, and the other way around. It, so SAS SAS to IaaS, AWS responsibilities decreases, and customers' responsibility increases. You just need to remember how much shared responsibility is allocated to both parties. All right. So, see that some of the exam tips and real world scenarios. AWS responsibilities, right? So it's got a physical data center security, network infrastructure, hypervisor management, global infrastructure. They have mostly the physical things will be maintained by these providers, right? And then you go to customer responsibilities. So they need to manage IAM policies and user access. They have to provide dedicated user access adequate, right? And need to make sure they are properly designed. And then data encryption and classification, what need to be accessed by whom, sort of things. And then they need to manage and maintain OS patches for EC2, operating system upgrade and patches. And then you need to make sure you got a network security, so security groups and network access control list, right? And so if anything comes questions involved physical security, mostly AWS, data protection, customer responsibility, OS patching, will be depend on services, right? PaaS mostly will be done by AWS, while IaaS, infrastructure as service, mostly done by customers. So real world scenarios, easy to instant compromise due to a missing OS patch, right? Whose responsibility is customers responsible, not AWS responsibility, right? Uh, I think today's discussion is going to end. Some of the documentation, source documentation I've been using for these videos. I believe that's what it is for today. And we'll see you from another discussion in another video. Until then, thank you very much.